Good morning, Algebra 2. We're going to jump into Lesson 50. The lesson practice is on page 358. And so this is talking about the inverse of relations and functions. And so we're going to learn as we do the lesson practice. So part A, it asks us to find the inverse of relation R. So here is relation R. They give us a table. And it states the following. So here's X, here's Y, 0, 3. They only gave us 3 points. Do I have that right? Yeah. Okay. So the inverse has the X and Y values switched. So it's really simple to find the inverse. Think of it as it doesn't really mean opposite, but so relation, the inverse of R, the table should be switched. So for example, instead of 0, 2, it would be 2, 0. Instead of 3, 2, it would be 2, 3. Instead of negative 3, 1, it'd be 1 and negative 3. So to find the inverse, we simply switch the values in the table. Really simple, okay? They'd like us to graph the two, and so that is what we're going to do. And I am going to put it here and here. And then we'll talk about their graphs. So here is negative 3, 3, 3, negative 3. This is X. This is Y. All right, so I'm going to talk about relation R. So I have 0, 2, 3, 2, and negative 3, 1. Okay? So I put this in blue. All right, for the inverse, I'm going to put the inverse. So I have 2, 0, 2, 3, and 1, negative 3. And so it asks us, what do we notice? And so something else I'm going to tell you about inverse functions. So not only are their tables switched, but their graphs should be a reflection across this line here is the y equals x line, where it goes through 1, 1, 2, 2, 3, 3. Like y literally equals x. Okay, so for inverse functions, our tables are, whoops, I said R, but I wrote and. The tables, the x and y values are flipped, and on our graphs, they are reflections across y equals x line. So within this example, we were to go over the two properties. And so I'm going to go ahead, I'm going to quickly tape this down, and we're going to move on how to do it algebraically, how to find the inverse. Not sure why I cut this huge piece of tape. What am I thinking? Sorry, it's Friday, even though I post this on I believe on Monday. So part B. Part B asks us to find an equation, find inverse equation of y equals negative 1/3 x minus 1. So the first thing you're going to do, step 1, switch x and y. just like we did in the table where we switched x and y, we do the same thing algebraically. So I'm literally going to write x here equals negative 1/3 y minus 1. Step 2, solve for y, which just means get y by itself. And those are the only two steps. So I would add 1. So x plus 1 equals negative 1/3 y. To get rid of that fraction, we multiply both sides by the reciprocal. So the reciprocal of negative 1/3 is negative 3/1. So on the left, I have negative 3x minus 3 equals y. Pretty straightforward, and that is it. Okay, part C. And I need to start writing on the back, but I am not sure how well that would scan. All right, part C asks us to find an inverse and determine whether they're a function. So find inverse of y equals negative 1/2 x cubed plus 1. And then we'll determine if they're functions. So remember, the first thing we're going to do is switch x and y. So x equals negative 1/2 y cubed plus 1. The next step is to get, next step is to get y by itself. So I'm going to subtract 1. So x minus 1 equals negative 1/2 y cubed. So to get rid of that fraction, I'm going to multiply by the reciprocal, which is 2/1, or just negative 2. I'm going to distribute the left, so that's negative 2x plus 2 equals y cubed. And the inverse of y cubed, any guess, is the cube root. So y equals the cube root of negative 2x plus 2. Then it asks, are they both functions? And we are going to graph using Desmos and use the vertical line test to test function. So on your iPad, I'm going to use my phone because I don't have a school iPad. I'm going to open up Desmos. I'm going to enter the original function first. There is a glare here and I apologize. So I'm going to type y equals, and then let's see here, I got negative 0.5, and then I need to enter x cubed, and then I forget how I come back down. Whoops. And then I have to negative 0.5 x cubed plus 1. All right, so there's the original, okay? If I drew a vertical line through this, it would only touch my graph one time. It's in your book. It's from Algebra 1. If you draw a vertical line through your graph, it only touches your graph once, then it's a function. So the original is yes, function. Now let's try the inverse. So I'm going to enter that as well. So I'm going to go ahead and delete what I had. All right, inverse, I need to find a root symbol. So I'm going to go to functions. I got to find the cube root. I'm going to use this here. It says it has the n cube root. So I believe I'm going to have to enter 3 first. So 3 and then functions, that, oh no, it comes up. So sometimes you just have to play around with Desmos, as you can see I'm as well. So functions, hit the functions button, and it lets me enter cube root, and then inside I'm entering negative 2x plus 2. All right, so here's the graph. And if I drew, and especially if you're unsure, you can zoom in. Oh, interesting. If I drew, and I'm going to keep zooming in. Oops. If I drew a vertical line, would it be a function? And I believe the only place it wouldn't be a function, and I'm going to checking in my head because -2 times 1 is 1, cube root of 1 is 1. -2 times, and it is a function, so yes. It looks like it wouldn't be because there's a straight line, but if you keep zooming, it has different points. Part D, I apologize, not number, part D. Find an equation for the inverse of y equals 1/2 x squared minus 4. All right, so it says find inverse, and then we're going to identify the domain and range of each. So first thing we're going to do is switch x and y. Right? So we're going to switch our letters. So x equals 1/2 y minus 4. First thing I'm going to do is add 4. So x plus 4 equals 1/2 y. To get rid of that fraction, I'm multiplying by the reciprocal, but I have to multiply everything on that side by 2. So I get 2x plus 8 equals y. Oh, there should be a squared here. Second is I'm going to take the square root. So y equals the square root of 2x plus 8. Now, it would like us to find the domain and range for each. Again, I'm going to use Desmos, and I'm going to write it here. So 1/2 x squared minus 4. I'm going to enter that in Desmos and find its domain and range. So let's see here. I have this all zoomed in. All right, so 0.5 x squared minus 4. And there's my graph, and I'm going to, okay, and I know that right there, it went by 2, so that's at -4. So I know that the domain is all real numbers because x can be anything. And my range is y is greater than or equal to -4, which is this guy here. And I also know it is a function. Now I'm going to check my inverse, the square root of 2x plus 8. So I'm going to enter that now. So y equals the square root of 2x plus 8. And so notice here, there we go. It is already limited, but notice my domain, I only have the top part of my graph. So I have, my domain is not all real numbers because the very first point is at -4. So x is what then -4 if it's pointing to the right. It is greater than or equal to. My range, the first value, if you click on this dot, the first value for y is 0. So y is greater than or equal to 0. And this is a function because if I drew a vertical line through it, it would pass. So that is the answer for D. Now in E, now technically the inverse is, I should have put plus or minus, but Desmos won't. Technically this inverse should be plus or minus, which would make it like this, and it would not be a function. But Desmos automatically limits it, so I should have changed it to this. y is, sorry, it's just that Desmos already limits it. In part E, they're asking what I would have to limit it to. So if I wanted it to be a function, I would have to limit these values of x to be greater than or equal to -4. That is what would make it a function. And the same with the range would then have to be y is greater than or equal to 0. E was not very helpful. I should have left that out and so that you could see the difference. Sorry about that. We are actually going to skip part F because you don't have a question that complicated on a test. For the homework, you're going to skip numbers 10, 11, 14, 15, 23, 26, and 29. Thank you.